Good morning, everyone. Welcome to Partnership for a Sustainable Future, Cutting Edge Innovations in Agriculture in Ibaraki Prefecture, Japan, and Emilia-Romagna region, Italy. Before we get started, I would like to just let everyone know that this webinar is being recorded. 皆さん、ようこそおはようございます。こんにちは。今日のウェビナーは録画されます。And also to let you know that you will be able to hear everything in English, including our speakers who will be speaking in Japanese. If you see at the bottom of your screen, there is an icon that looks like a globe. If you click that and select English, you will be able to hear English the whole way through the webinar. そして、日本からご参加されている皆さん、下にある地球のアイコンを押していただければ、日本語っていうオプションが出てきますので、日本語を選択してください。登壇者が英語で発表しているときは、日本語の同時通訳が流れます。Thank you very much.
Those people who want to listen to the contents in English, please choose English and choose the Japanese for Japanese language interpretation.
He's going to give us an opening speech. Over to you, Jeremy.
Thank you, Hannah. So good morning, good afternoon, and good evening to everyone who's attending. I just want to say CREAB is very proud to welcome you to the webinar today between Ibaraki Prefecture in Japan and Emilia-Romagna region in Italy, focusing on their partnership for a sustainable future, which is cutting-edge innovations in agriculture. We will see two welcome addresses via video message from the governor of Ibaraki Prefecture and the president of Emilia-Romagna region. Following this, we'll hear from 9 separate speakers coming from both regions. So I'll now hand you back again to Hannah, who will introduce the first section. Thank you.
Thank you very much, Jeremy. So first of all, we have a video message from the governor of Ibaraki Prefecture, and I will press play on that now.
Hello, I'm Kazuhiko Oigawa, governor of Ibaraki Prefecture. Welcome to this joint webinar between Ibaraki and Emilia-Romagna. Today, we come together to discuss the theme of new technologies and methods for the future, with a focus on agriculture and food products. Ibaraki Prefecture is renowned for its high-quality agricultural products, including melons, sweet potatoes, beef, and pork. We take great pride in our agricultural heritage and are dedicated to promoting sustainable practices that benefit our communities. Additionally, Ibaraki is home to Tsukuba Science City, a leading research and development hub in Japan. This city fosters innovation and collaboration between academia, industry, and the government, driving economic growth and creating new opportunities for innovation. Our partnership with Emilia-Romagna region dates back to 1986, established after the expo held in Tsukuba. We have since fostered cultural exchanges and cooperation between our region. We extend our warmest greetings to our friends from Emilia-Romagna and commend your commitment to sustainable development and innovation. This joint webinar serves as an excellent occasion for collaboration and knowledge sharing. We hope to learn from one another and explore new opportunities for the cooperation. We believe this event will provide you with a better understanding of our region and invite you to discover the unique charm of Ibaraki Prefecture. Thank you for joining us today, and we look forward to your active participation in this exciting event. Thank you. Hello.
So that was the opening speech from the governor of Ibaraki Prefecture, and now we will see a short video from the president of the Emilia-Romagna region.
Cari amici di Ibaraki, un affettuoso e caloroso saluto insegno anche della nostra straordinaria e duratura amicizia nata tra la prefettura di Ibaraki e la regione Emilia-Romagna addirittura nel lontano 1986 e che ha saputo rafforzarsi nel corso di questi decenni, da ultimo la visita di una delegazione istituzionale e di imprese proprio qui a Bologna poche settimane fa in occasione di Sana, di una grande fiera, di una fiera internazionale nella quale abbiamo potuto ulteriormente rafforzare la nostra collaborazione, scambi di opinione, anche in previsione della missione che faremo a novembre. Sarò presente anche io in Giappone portando la cucina emiliano-romagnola, la straordinaria cucina e i prodotti agroalimentari della nostra regione in Giappone. Abbiamo scelto il vostro paese quest'anno come meta annuale per portare le eccellenze culinarie emiliano-romagnole. Saremo a Tokyo, saremo ad Osaka, che sarà sede tra l'altro nel 2025 dell'Expo Universale, e anche e soprattutto saremo proprio da voi per rafforzare gli scambi, in particolare questo webinar che affronta il tema dell'innovazione in campo agricolo ed agroalimentare, mettendo insieme le forti competenze che i nostri rispettivi territori possono garantire per affrontare tutto ciò che ci aspetta in campo di nuove produzioni agricole, di salubrità dei prodotti e soprattutto per un'agricoltura che sia sempre più di qualità. Non vedo l'ora di venire nel vostro paese, nel vostro territorio, nella vostra prefettura, e non ho dubbi che sarà un'occasione molto proficua per rafforzare la collaborazione e le attività che insieme, pur stando in due parti del mondo così distanti ma così vicine, per gli sforzi e gli obiettivi che ci vogliamo dare per garantire ai nostri cittadini una sempre maggiore qualità della loro vita e delle loro vite. Grazie anche da ultimo per la generosa offerta che avete fatto in occasione della recente drammatica alluvione che ha colpito l'Emilia-Romagna. Pensate che è stato nei primi 9 mesi del 2023 è stato classificato come uno dei 3 avvenimenti più catastrofici al mondo. Grazie per quello che avete fatto in segno di amicizia, di solidarietà. Ci ha fatto molto piacere e vi devo dire ci ha anche commosso. Grazie e a presto.
So that was our opening video from the president of the Emilia-Romagna region. So before we get started, I'll just give you a quick overview of how today's webinar is going to look. So we've just had our opening speech and our opening videos, and after I'm done speaking, we'll move on to our actual presentations. We have 9 presentations today. 5 are from Ibaraki Prefecture and 4 of them are from the Emilia-Romagna region. Our first speaker actually is joining us from America, and so he may have to leave early due to the time difference. So we're going to have a short Q&A session just for him immediately after his presentation. But for all of the other speakers, we'll have a longer Q&A session at the end of the webinar. So please, throughout the webinar, please put all of your questions in either English or Japanese into the Q&A box, and we will go through all of them, as many as we can with the time that we have at the very end of the webinar after the presentations. And finally, once we've done our Q&A session, we will have a closing speech from Jeremy again, and then we will be done for the day. So without further ado, I'd like to introduce to everyone our first speaker. Our first speaker is Kotaro Kawajiri. He's head of research and development at the company Aizoth. His presentation is titled No-Code Cloud AI Analytical Platform Multi-Sigma and AI-DOE to Revolutionize Research and Development. Kawajiri-san is going to talk about Aizoth's product Multi-Sigma and how this AI analysis technology can be utilized in the field of agriculture. And as I said before, Kawajiri-san is joining us from America. And so we're going to hold a quick Q&A session for him right after his presentation is finished. So throughout his presentation or just afterwards, if you have any questions for him, please put them in the Q&A box. Kawajiri-san, welcome. Please start your presentation.
こちらで見えてますでしょうか？
はい、見えてます。
Okay, let's start. Hello everyone, and thank you, Claire of London, to give us such a great opportunity to have my presentation. My name is Kotaro Kawajiri. I'm a founder of Aizoth, and also I'm a head of research and development department. And today I'm going to talk about our no-code cloud AI platform, MathSigma, and how to apply it to case studies of agriculture's field. And actually, I worked for National Research Institute in Japan, and actually our business so well, then I need to quit my job last month. And now I focus on my business right now. And our business, Aizoth provides some AI services such as MathSigma. This is our main product. And the other one is consultation using MathSigma or other AI techniques. And also some support to find optimal parameters before setting some operating conditions to manufacture some product. And the final one is commissioned R&D. And in short, we are specialists of numerical AI. Maybe you may imagine, if you hear AI, you can imagine ChatGPT or generative AI or using image. But we are the specialists by numerical AI. So we could say our software, our services is like a generative AI or numerical field. And let me start from my motivation to make our product, MathSigma. And when I was a PhD student, I produced such nano materials using big plasma machines. And it has many controlling parameters. And also it has multiple objectives to optimize the conditions. If you set 10 options for each input parameters or each experimental condition, then the combination of experimental condition is 10 powered by 7. And it is impossible to try all of such combinations. And also the problem is we need to pursue multiple objectives. If you improve one objective, the others are decreased. And at most problem is the machine is quite large and it takes 1 day to get one experiment. So it is impossible to try every combination of experimental parameters with using such a big machines. So I'm so suffered with such a large effort to optimize such conditions for multiple objectives when I was a PhD student. So we developed our software MathSigma to solve such a problem. And in this slide, I will show you how it works. At first, you upload your experimental data. Then you can predict the result by using deep learning method. Deep learning means neural network, and also you can switch it to Bayesian analysis. Then you don't need to do additional experiment after training AI. AI can simulate the result. The next one is MathSigma can optimize inputs for multiple objectives. So you can get the optimum conditions for multiple objectives. The last one is factor analysis. Usually people say the problem of AI is a black box and you cannot understand the cause and effect inside the mechanisms. But Mud Sigma have function or factor analysis, and you can easily understand the cause and effect between inputs and outputs. And we have a great auto-tuning system to prevent overfitting even with small amount of data set. And Mud Sigma can deal with input up to 200 and output up to 100. And please imagine you can optimize input of 200 parameters for 100 objectives. And you can do that with using the data size from 3 to 20. That is the minimum line of the data size. The maximum is 3 megabytes of the data. So I feel that this technology is quite great to innovate research and development to reduce the effort of trial and error by human beings. And you don't need big data to use our softwares, and you don't need to program by yourself, and you don't need to hire data science, and you don't need to buy some special hardware such as GPU server or something. And it can run even on smartphones like that one. So we can say anyone can use it on anywhere and on any hardware. And it was released 2 years ago, so it is a really brand new softwares. But now we have more than 100 users in Japan. Most of them are large enterprises and top universities, like that. And Kagome is a big food company in Japan to produce some tomatoes. So it is well matched to agricultural field. And compared with other machine learning tools, the advantage of Multi-Sigma is it can deal with multiple outputs, and it can optimize the input for multiple objectives. Usually, people think the AI can do everything, but actually the algorithm of prediction and optimizations are quite different. The advantage of Multi-Sigma is combining the AI of prediction and optimization. There is no such a software in the world. And this is a case of applying our software to design of artificial heart. And it has 4 design parameters, and the total combination is more than 7,000. And it costs $7,000 to produce 1 unit. So you cannot try every combination of parameters. And it has also 2 objective parameters. And at first, we set 30 to 60 experimental conditions at first at random, and get the result by doing experiment. And finally, we could get the optimal design parameters. And comparing with the total number of combinations of experimental conditions, we could say 19% of experiment to find such innovative conditions. And it was released from some news, and this software is quite general one, so you can use it for any types of research field. So application is quite large. And fortunately, we could get some awards. As you can see, we have we take a picture with governors, and also this is the largest prize for venture companies in Japan. And from here, I will explain the application of our softwares to agriculture field. And we have some field to use these softwares. The application, the first is the prediction of something. We use these softwares to predict some production of vegetables such as potato, or this is a picture of Kagome agricultural field. And they released some press release that we are collaborate with to produce such a prediction softwares for their farms. And also Senior is an Italian guy, and now he works at Kyoto Universities, and he is a student right now. He apply our software to predict some grade of meat by using the health conditions of cow. And also it can be useful to predict some health conditions. The prediction is quite high. And also, yeah, we apply it for some chemical that predict some chemical properties of ingredient of food. The next one is diagnosis of quality or anomaly or disease. We apply our software to predict some quality or anomaly or some disease of food product. And the final one is optimizations. We applied our software to operate some food plant, and it works well to optimize the operating conditions of such a food plant. And our software is quite useful for tailor-made optimization. That technology is quite well matched to agricultural field. If you train the data with attributes of some livings, and also you add some treatment data and train AI, then you can optimize for specific treatment parameters for specific with some specific livings. So by using these technologies, you can predict some quality and how to manage the daily care for cows or any agricultural livings. And as I explained before, such application of our software is quite good, even for agricultural field. And now we believe that our software is well good to reduce the environmental impacts of our society. And thank you. And if you have any question, please contact me anytime. Thank you.
Thank you very much, Kawajiri-san. If it's okay with everybody, I would like to move on to a Q&A session for Kawajiri-san. So if you have any questions, please put them in the Q&A box below, and that can be in English or in Japanese. So here is a first question. Surely living things such as plants or livestock act or grow in quite unpredictable ways. How does multi-sigma account for this?
Yes. You can predict such a unpredictable behavior by adding the data, including the data in a status of unpredictable conditions. Then you can predict such unpredictable conditions. But if you don't include such unpredictable conditions, you cannot predict it without using the actual data. Yeah. So the point is, you should include such unpredictable conditions to train AI.
That makes sense. Thank you very much. Does anyone have any other questions for Kawajiri-san? Oh, here's one. Is there scope for individual or small family farms to utilize this technology down the line, or is it mainly targeted at larger scale?
As I said, you can use our software for any types of research, and there is no such a difference between the big company or small farmers. So anyone can use it. And also, yeah, actually, in the case of food plant, it is not a small farmer, but yeah, it is a one user and a little bit middle-sized farmer. So yeah, so even a single farmer can use our software if you want to use.
Brilliant, thank you. I think we might have time for just one more question if there's another one from anyone. Okay, if there's no more questions, then I might wrap it up there. Thank you very, very much, Kawajiri-san, for your wonderful presentation. Up next, we have a presentation from our first speaker from Emilia-Romagna. It's Giuseppe Moscatelli. Giuseppe is a researcher from CRPA, the Research Center on Animal Production. His presentation is titled Gas Loop, Ammonia Emissions Capture for a Virtuous Nitrogen Cycle in Pig Livestock. He'll be explaining to us how their project can contribute to animal welfare and productivity by capturing the ammonia emissions that are produced in pig farming. Welcome, Giuseppe. Please start your presentation.
Okay, good morning. Thanks, Anna, for your welcome. Now I show my presentation. Okay, I put it at full screen. All is okay for you?
Yep, we can see that, but it isn't full screen yet for us.
Yes. Okay. This presentation will explain the innovation, the idea behind the gas loop project. The project is related to ammonia emissions capture for a virtuous nitrogen cycle in pig livestock. The project was funded by Emilia-Romagna region in the thematic topic of the operational group for the innovation in agricultural sector. What is the problem addressed? That of ammonia emissions from pig livestock in the Po Valley, where Emilia-Romagna region is located. As you can see from the satellite image, the Po Basin area is among those in Europe with the highest ammonia gas concentration, and ammonia causes health problems to livestock farm, to human health and odor, and it is also an important precursor of fine dust. The Po Valley in Italy represents one of the areas with the highest concentration of particulate matter. The goal of the innovation is to transform ammonia emissions from a problem to a fertilizer resource, to generate a nitrogen virtuous cycle or loop in the pig farming, which producing ammonium sulfate recovered fertilizers by capturing ammonia emissions, reduce also the chemical input for the farming crops and consequently the greenhouse gas emissions generated by fertilizers industrial production. The main project tasks were develop a pilot able to clean the air and to recover ammonia, and implement the system up to a technological maturity level equal to 9, ready for market. Other tasks were monitor, evaluate the air washing treatment efficiency, the ammonia emissions avoided, the enhanced indoor air quality for human and animal. Also produce, quantify, and characterize the recovered fertilizers in a view of nutrient recovery and circular economy, evaluate GHG reduction, evaluate the increasing of the animal welfare and productivity due to better air quality inside the pig housing. At the end, dissemination of the activity and the results, training and demo visit to make sure this innovation to the farmer. Here in the picture, there is the pilot system to treat the air. The device draws ammonia-rich air from pig rooms through a suction duct located below the slatted floor, where under there is the pit to collect pig manure. In this way, the emissions from the slurry don't rise and pass through the slatted floor into the room above, but are sucked up by the treatment system. The air treatment is based on chemical absorption of ammonia by countercurrent acid washing into this tower. The process takes place at pH 4, 4.5, and a sulfuric acid solution is used as absorbent matrix. Ammonia as a base is salified by the sulfate ions, and a liquid solution containing ammonium sulfate salt is produced. During the cold season, a quart of the treated air without ammonia is recirculated into the room in order to not dissipate the heat, while in the hot months, the treated air is exhausted outside to implement the ventilation of the stable. As we can see, the ammonia concentration in the treated room, in this line red, compared to near identical but not treated rooms, in this line blue, control room, is reduced in every season of the year from the 57% to 67%. And the higher treatment efficiency of the device between the ammonia content input and ammonia content output in the treated flow is about 80–90%. The treatment system during the monitor here made it possible to recover nitrogen, particularly 14.5 kilograms of nitrogen recovered per year per ton of live weight in the rooms. Given that expressed as ammonia emissions means ammonia emissions avoided for 17.6 kilograms of ammonia per year per ton of live weight, or 1.9 kilograms of ammonia for animal place per year. The innovation not only reduce ammonia emissions, but also enable the recovery of ammonium sulfate solution with a nitrogen content in average of 4.9% in weight, and in some cases as a maximum of 6.4%. And the mineral ammonia nitrogen form inside the solution is for the 99% in a mineral form of this parameter linked to the very, very low content of total organic carbon, only the 1.2, 1.3% in weight, and the very, very low carbon-nitrogen ratio, make this ammonium sulfate solution produced complying with the European regulation on fertilizers and can be sold as a mineral inorganic fertilizer. Moreover, this production of ammonium sulfate can reduce the GHG emission due to replacement of nitrogen industrial fertilizers. And we were able to reduce of 66 tons of CO2 equivalent per year per ton of live weight. Moreover, in another project, Resurge, we are testing this recovered ammonium sulfate instead of chemical industrial fertilizers on sugar beets and basil crops. The final crops production yields don't appear to be lower compared to those fertilizers by urea nitrogen industrial fertilizers. Indeed, in the case of basil, even higher. Animal welfare and productivity are also investigated, and this table shows how the main productivity parameters are better in the treated rooms compared to the pig grown up in the control rooms, even if with low difference. Only the absence of lung injuries at the slaughterhouse was significantly higher in the higher treated rooms pigs compared to the pigs grown in the control rooms. One note has to be shown. The trials were carried out in a pig livestock which already adopt a high animal welfare standard and complain to the DPO Parma Harm disciplinary. This slide only to show you this link to the Nutrino EU platform, because gas loop has become part of the Nutrino platform. Nutrino is an European project, and in this project, one of the innovative nutrient management solution was a gas loop, together with other 12 solutions derived by other 12 operational group. At this link, more information will be available in the next 2 years on this European topic of the connecting farmer and the science, and to explain and disseminate the correct management of nutrient in the agricultural sector. To be concluded, the air treatment with ammonia recovery as fertilizers was technically feasible. In our case study pig farm, with a total live weight of 1,150 tons, results recoverable nitrogen in a year for 16.8 tons, with consequently ammonia emissions avoided for 20.3 tons of ammonia per year. The ammonia concentration in the livestock room is reduced and ammonia emission consequently reduced. This means a better animal welfare and worker health and an higher yield for the productivity of the pig. nitrogen recovered in ammonium sulfate solution could be valorized as a mineral nitrogen fertilizer in the pig farm or in an external trading, nutrient recovery and reuse topics. But at the end, the impact of the pig production cost of the innovation for reducing ammonia emissions is problematic. Cost increase of 7.3% for kilograms of meat produced. Related to the value of the meat in Italy today is the 7.3% of €2.3 per kilograms of pig meat produced. As is often the case, systems to reduce environmental impact produce more cost for the farm than economic benefit. Funding support may be welcome. And moreover, the production of recovered versus synthetic fertilizers should be economically promoted or supported. Thanks all for your attention. This is the image where the trials are carried out.
Thank you so much, Giuseppe-san. If anyone has any questions for Giuseppe about his presentation, please put them in the Q&A box and we'll come to them at the end when we do the Q&A session together. Thank you very much. So next, we're heading back over to Japan. Our next speaker is Shin Sukegawa. He's a researcher from the Research and Development Center at NH Foods Ltd. His presentation is titled Research and Development for Digital Transformation in Pig Farming, PIG LABO. So Sukegawa-san will explain to us how PIG LABO, which is a project developed in collaboration between NH Foods and the NTT Data Group, is using AI and Internet of Things technologies to improve labor productivity in pig farming. So over to you, Sukegawa-san, please start your presentation.
My name is Sukegawa from NH Foods R&D Center. I'd like to thank Ibaraki Prefecture and Emilia-Romagna for the opportunity to talk at the webinar today. I'm engaged in research and development with the aim of solving problems in the livestock industry and making the livestock production, especially pig farming, more attractive through utilizing digital technology. Today, I'd like to introduce our research on pig farming and AI and talk about the PIG LABO, which we developed as an outcome of our research. So first, let me briefly introduce my company, NH Foods. NH Foods is a global company with a corporate philosophy of the joy of eating and is expanding the business globally, centered in Japan and in North America, Asia, Europe, and other regions. In Japan, we mainly supply processed meat products such as meat, ham, and sausage, as well as a wide range of food products such as pizza and frozen foods. The photo on the right-hand side is a picture of our products. In addition, we operate what we call a vertically integrated system, which means that we operate all the various processes from the livestock farming on the farms to food processing, manufacturing, distribution, and sales and marketing. NH Foods has 3 facilities in Ibaraki Prefecture, including factories and a research center. The R&D center where I work is located in Tsukuba City in Ibaraki Prefecture. We are conducting research on a wide variety of topics, for example, food safety, and also animal breeding technology, disease control, and also food allergies, and also inspection technology and new protein sources. So in this way, our researches cover a variety of topics. My team conducts research on livestock production, especially pig breeding. The Japanese pig breeding is facing a variety of challenges. Among the diverse challenges are high feed prices, disease, animal welfare, and more than anything else, a lack of human resources. The conventional way of pig farming, pig breeding, which relies on human intuition and experience, is becoming difficult to sustain, and the change of transformation is required. And then so to that end, we are conducting a research project. So about the challenges, I'd like to explain more by using the data. So left-hand side shows the global meat demand forecast. Demand for beef, pork, and chicken is all increasing. And for Japan, which imports meat, the importance of domestic meat production and supplies is expected to increase. And it means that there is going to be a fierce competition to meet the demand for the Japanese market. So it means that the meat domestically produced is going to be even more important. The right-hand side, on the other hand, shows the demographic trends by age group in Japan. Japan expected to have a declining birth rate and aging population, and overall population expected to decline. Currently, the percentage of the population over 65 years old is about 30%. The percentage of the younger generation, on the other hand, is showing a declining trend. So this means that there will be a shortage of human resources. And in addition, livestock and agriculture industry is experiencing shortage of human resources because it's not being very attractive to the younger generation, that we predict that it's going to be even more difficult to hire employees. And therefore, we need to make a mechanism where anyone can get involved in the farming and then also the pig farming. So in order to solve this, we developed this system called PIG Lab. And as a livestock and food company, we have experience and know-how in farms and related fields, but we do not have IT technology. So we collaborated with NTT Data, one of Japan's leading IT companies with strengths in communication and AI development technologies. And by bringing our strengths together, we developed useful technologies for breeding management. So I'd like to explain to you about the PIG Labo. First, electric devices such as sensors, cameras, and microphones are installed in pig farms to monitor the farm environment and pig behavior. The first step is to make the data visible, but farm workers are always so busy, and they do not have time to look at such a huge amount of data or making the judgment based on that data. So we are now having AI analyze these data and make judgments about the situation. Then we can make it work more efficient and respond to the situation more quickly. In pig farming, the work changes at each stage of the pig's growth, from the breeding stage to fattening and shipping. We believe that by supporting each operation to improve their productivity at every stage, we can provide total support for pig production and achieve significant benefits. Our goal is to first develop and launch functions which are in high demand, then introducing new functions one by one, and ultimately increase overall productivity of all aspects of pig production and management operations. So How are we going to use AI in pig farming, and then also how are we going to develop this? So livestock production has traditionally relied on human judgment. Judgments including body condition, timing of farrowing, approximate size, and environmental adjustment such as heat and cold. And so all of these have been judged by human. At first, we accumulate factors that until now have been perceived sensibly by humans as big data on pigs. We collect data for their behavior, squeals, and posture, collected from cameras and microphones, and environmental information. And this information can also be collected from sensors. On the other hand, there is a set data on the condition of the pigs at this time, which is determined by people, by human. And this information becomes teacher data. So we combine the teacher data with the collected data. Then, by combining these two pieces of data, the relationship between the pig condition and behavior will become clear, and it will be possible to build an AI that can automatically judge the pig's condition. I'd like to introduce you one of the technology that we have developed in this way. It is function we call PIG LABO breeding master. So it is AI that determines when a sow is in estrus. In other words, to make judgment about the timing of sowing. Conventionally, estrus is a judgment made by the pig's appearance, behavior, and reaction to touch. But we can now analyze the pig's behavior to determine whether the pig is in estrus or not. And one in estrus is showing in red, and the confirmation required is in yellow, and the no estrus is in blue. So we have developed this technology as a system and an application and make it a product. On the slide is a picture of the actual screen. So you can see the color of each pig that you will know when to sow each of the pigs on that day. And the farm workers can check the results and work with them every day to avoid missing the timing of the sowing, and then also to reduce the effort in checking the estrus. So this system was used and worked on actual farm for 6 months. As a result, conception rates and piglet production performance have improved compared with conventional estrus confirmation by skilled workers. On the other hand, the system has reduced the workload for estrus confirmation operation. In this way, through the use of digital technology, we believe that by leveraging digital technology, we can improve and stabilize performance and reduce labor without relying on human experience. So finally, by utilizing the digital technology as PIG LABO in livestock farming, we aim to contribute solving the social issues for pig farming, not just for our own company, but also to the big industry as a whole. And we would like to continue to develop and commercialize the results of our research into the future. Thank you very much for your kind attention.
Thank you very much, Sukegawa-san. Attendees, please put any questions that you might have for Sukegawa-san in the Q&A box, and we will come back to them at the end of the webinar. So next we have another speaker from Emilia-Romagna region. We have Ambra Motta, who is also a researcher from the Research Center on Animal Production. Ambra will be presenting about CRPA's project PARSUT, which stands for the Parma Ham High Sustainability Standard. This project aims to create a more ethical production chain for Parma ham, which Emilia-Romagna is quite famous for. So over to you, Amber. Please start your presentation.
Thank you, Anna. I try to share my presentation. I ask you if you see my screen.
Yep, we can see that.
Perfect, perfect. Thank you for this opportunity. As Hannah told you before, my name is Amber Motta and I'm a researcher at CRPA, Research Center on Animal Production. Today, I will show you a presentation about Pursuit project. Pursuit is a project funded by the Rural Development Program 2014-2020 of the Emilia-Romagna region. It is an operational group project for innovation, and this type of project enables cooperation between research organizations such as CRPA and productive world, so farms, slaughterhouse, and factories. The project is still ongoing, so today I will give you an overview of the goals and the activities, and I will report some results. Pursuit project wants to create a permanent production chain model with extra qualities added to the PDO that can meet the demands of Italian and foreign consumers. And in particular, it wants to develop a technical protocol which includes high standard of animal welfare, biosecurity, and responsible use of antibiotics in pig farms. However, this protocol has to consider two fundamental aspects. It has to be economically sustainable and it has to have a low environmental impact. Some of the activities of the project are focused on breeding, so on farm. National and international standards were revised in order to identify a list of relevant parameters to be included in the protocol, considering also their feasibility in pig farms. The identified parameters were submitted to more than 100 stakeholders, such as farmers, veterinarians, agronomists, animal NGOs, to refine this list and select the most relevant measures for animal welfare, biosecurity, and responsible use of antibiotics. Then a list of animal welfare indicators for sows, piglets, weaners, and also fatteners were submitted to 32 international scientific experts for the final selection. This online consultation resulted in a draft protocol and data collection checklist that were tested on a number of farms. On the basis of these assessments, it was possible to identify which improvements were needed on farms to comply with the protocol. CRPA now is going to calculate investment and management costs of the proposed improvements. We define investment cost as construction or renovation costs of buildings and also cost of equipment and facilities. The main requirements included in the protocol are related to research-based measures, for example, type of housing, type of flooring, drinkers, feeders, enriched materials, are related also to the direct control of animal-based indicators, such as lameness, wounds on the body or tail lesions, and also behavior, and some aspects about biosecurity and responsible use of antibiotics. In this slide, I give you some examples of what stakeholders and scientific experts suggested to us on online consultation. For example, no cages or temporary crate system for lactating sows, a comfortable resting area with solid floor and the ban of a fully slatted flooring system, also increased floor area per animal compared to the minimal legal requirements, and at the end, the availability of rootable and fibrous material as enrichment materials. So this is the main requirements of the protocol, of Pursuit Protocol. Regarding biosecurity, some of the parameters included in the protocol are the strict application of all-in, all-out system, complemented by cleaning and disinfecting the facility for the new group and the new batches of pigs. A sanitary break, that is a period in which the piggeries, so the facilities, are empty before the introduction of a new group or batches of pigs. They suggested us also to establish the rules for entering into the facilities. As you know, people and vehicles can be important pathways for the introduction of a new disease in the farm. So the risk associated to visits may be minimized by a combination of barriers, such as a clear delimitation of clean and dirty area, or a perimeter fence, or the use of disposal clothing, boots, and gloves, or also an arc of disinfection for vehicles. Other activities of the project focused on the supply chain. For example, traceability of high standard Parma ham along supply chain, economic and environmental sustainability, not only for farm and for farmers, but for the entire supply chain, and also market outlets. As I told you before, not all the activities are concluded. Here in this slide, you can see the results of the survey at large-scale retail trade. The survey, conducted in the mass distribution circuit on 34 important distribution chains, has underlined a growing interest for control quality chains that improve also animal welfare. So more than 90% of respondents, so of the retailers, the large retailers, are interested in a Parma ham with these characteristics. So high standard of animal welfare, biosecurity, and responsible use of antibiotics. Since breeding farming with high animal welfare standards means higher costs for farmers, buyers, so the retailers, were asked what price increase they would be willing to accept. 33% of large retailers would not accept any price increase, while 50% would be willing to tolerate an increase of 1.5 euro per kilogram. Almost of the buyers interviewed believe that consumers would not be willing to accept any price increase, while the other half believes that the acceptable increase could be between 1 to 3 euro per kilogram. Most respondents also believe that there is a 30–50% chance that their brand, so their retailer, will include a line of Parma ham based on this kind of protocol, so with high animal welfare standard and also high standard of biosecurity and responsible use of antibiotics. The survey conducted also underlined the importance of a specific packaging, a self-dedicated and label information for Parma based on a protocol with this high standard level. Moreover, we asked the respondents what are, in their opinion, the barriers, the obstacles to the adoption of this kind of virtuous protocol. And the main ones are the investment cost, the management and labor cost, and also the reduce of the number of places in farm. So this is a pursuit project, as I told you before, is still ongoing. So if you want to know something else, or if you want to follow the results of this project, please visit our website. Thank you.
Thank you so much, Ambra, for a wonderful presentation. If anyone has any questions for Ambra, please put those questions in the Q&A box and we will come back to them at the end of the webinar. So up next, we have Yoshiharu Yamamoto, who is the CEO of Vision Tech Incorporated. His presentation title is Our Initiatives in Satellite Data Business and Agri-ICT. Yamamoto-san will be presenting Vision Tech's products, which are AgriLook, Wagri, and the TELUS satellite data platform. These are products that can use satellite technology to help farmers to optimize their products. Please start your presentation, Yamamoto-san.
Good morning. I am from Vision Tech. I am Yamamoto. First of all, I would like to share my screen. Today, I am very grateful that I was given this opportunity to give a presentation regarding Vision Tech. I would like to talk about our initiatives in satellite data business and Agri-ICT. Vision Tech was established in 1997 in Ibaraki Prefecture, Tsukuba City, regarding remote sensing company using satellite. To start with, we were selling satellite images and infrastructures related information service. And then we are offering information services using satellite data. And then satellite information, particularly agriculture, is our strength. So AgriLook is one of the information technology. We started from 2009. And it was an in-house development of agri-info distribution system, so that the Japan as a country, they can create a strategy for the agriculture. Therefore, the researchers for agriculture can integrate all of these information, and so that they can put the research study to implement as social implementation. So we have developed all of these programs, not only used by us, but also we wanted to offer to other companies as API. So it is an open API system, and this is on the platform called Wagri. This is Agri-Info Alignment Foundation Group. So this is another part where we take part in. And then regarding our business, as I mentioned, remote sensing field, the analysis and the multispectral related information. So we are also offering image processing analysis software. But today, in particular, we would like to talk about AgriLook. In addition to AgriLook, we have Sakumo, which is a growth management information distribution service, and also Web API. So all related to crop information. So growth prediction system, that is what we are developing and offering as a service. And Vision Tech, we started in 2002. Iconos was in the United States, started as a satellite data. So that was the beginning of our company. Then in 2007 onwards, we have started various research. And when we did the market research, we decided to develop the AgriLook. This is based on the funding from the ministry. There were three. One takes about 3 years. Therefore, it took altogether 9 years for 3 AgriLook. So from the Ministry of Agriculture has informed us that they particularly wanted us to develop crop growth system, prediction system. So we are still working on this continuously. And this AgriLook, from next year, we will start implement overseas. So as a part of JICA project, we will start using this system in Sri Lanka. So what is AgriLook? I would like to explain quickly. It is satellite and also meteorological data are combined together so that it is easy for people to make use of it, and it is visualizing these possible data together. So if you could connect to this homepage, and if you have a contract, you can make use of these information and data. So because this is a web system, you can make use of it from your mobile phone or a tablet, and it is all available to use to check the actual status of crops in the field and also the prediction data. You can compare them together to make further information available. So basically, we are providing the information about the growth situation, such as changes and the growth stage. And then the satellite data will show if it is really growing as we predicted or not, so that the farmers can make use of these information to make judgment for their work. So, in order to visualize AgriLook, we put it on top of the map. So the map will be the base, and then we will put information overlaying over the map. So what is important here is that when you wanted to look at the field, then the farm polygon information coming from the Geographical Survey Institute in Japan, and each individual field that we can check from the satellite data and visualize that information so that they can easily identify what they are looking for. And regarding meteorological information, Japan Meteorological Agency has a Amedas. This is a meteorological data, and they have about 800 points in Japan. So they have a quite good resolution. And in Japan, there are a lot of mountains. Therefore, sometimes the accuracy goes down. Therefore, we decided to choose the 1 kilometer square mesh on the map and then check the temperature and the rainfall so that they can make more prediction. And then this is the image of Japan from the satellite data. When you just use one image, then the resolution is rather rough. Therefore, what we are using at the moment is Sentinel, which is a European satellite, which has a 10 million resolution. So we use this. We can make about these images in about 5 days. So what you can see here is 2019 to 2021 image of summer. So August, 1 month's data is put together. The white on the picture is cloud. So basically for 1 month of August, they had cloud in these areas. So you can see which city or which area, what kind of possible disaster, or you can see. For example, in August 2019, you can see a lot of clouds in the Kyushu area, and then in 2020 in Hokkaido. So from 2019 and currently we are in 2023. So we made all of these information into database so that we can get a data without these cloud covering the map. So once we have this basic data, based on this, next year onwards, we should be able to make use of the satellite data prediction can be combined to this basic information. And then, as I mentioned earlier, this is the meteorological information. So it's about temperature, solar radiation, daily precipitation. They can check this every day, and based on this, we can check gross information. So in case of rice, they can predict possible protein contents. And then we also have a diagnosis information, what kind of top dressing they need, more additional fertilizers, and also when the optimum harvesting period might be. This is the kind of thing they can check. In addition to this, now we have the global warming. Therefore, we can check the growth obstacle information, so we can display predicted risks. And then the customer's information can be registered onto our server and make it into database. So that is also possible. So meteorological information and the growth information, particularly in Japan, rice, soya bean, and in Japan, we have 150 different types of information on rice. So we have this Wagri utilization for gross pre-estimation information is combined to AgriLook. So other companies' information and various information combined so that the vendor can create the combination of their liking to make better information together. So this is open. Of course, this is not a free service, but you can make use of this. So Wagiri, also we are using meteorological 1 kilometer mesh information. That portion is free of charge. Therefore, people can use this information freely. Therefore, crop-related basic information is made available, such as meteorological information and the diagnostic information. So these are offered by our service. And then for satellite information, this is also Ministry of Economy and Industry mentioned TERUS. This is another TERUS Eisei data platform. In this, slightly different from the one I've shown you before, but from 2021 to 2022, we are showing various information. This is the nationwide vegetation index image, a slightly rough resolution, but by using this, you can make various statistics and various data of your wish. So every 5 days, there's satellite information and 10 million resolution. So we are preparing so that this will be available soon. Here, I would like to show you one example of AgriLook. What you can see here is Hokkaido Shinshino City area. So it's all color-coded. This is 24th of September. This is a picture we have taken from satellite, and it's color-coded. The reddish color is not much plant activity, so it may not be crops. So you can see that from the color. The very green area is plants. So this is September. Therefore, the reddish area might possibly be rice close to harvest, and yellow and green. This area may be soya bean. So you can see that from this map. And also, this one is from Japanese satellite system. The blue area is water. So from satellite, you can check.
Thank you very much.
Thank you very much.
Thank you very much, Yamamoto-san, for that wonderful presentation. So sorry to cut you off at the end there, but we're running a little bit over. But so everyone, if you have any questions for Yamamoto-san, please put those in the Q&A box below. So next we have another presentation from Emilia-Romagna. We have Camilla Lazzi, who is an associate professor at the University of Parma and also is a scientific manager of Ce Fermento. Her presentation is titled Development of New Lacto-Fermented Products Based on Fruit and Vegetables. And Camilla is going to tell us about her research activities and how these new lacto-fermented products can benefit the agricultural industry. Please go ahead, Camilla. Thank you.
Thank you, Anna. Can you see my screen?
No, not yet.
Oh, sorry. Probably now.
Yeah, now we can.
Okay. Okay. Good morning to everybody, and I want to thank the committee for this invite and for giving me the opportunity to talk about this topic. It is a very pleasure to be here today because I concluded a research project fairly recently with a Japanese researcher. It was a project funded by the Ministry of Foreign Affairs and International Cooperation, and it allowed us to create a new scientific network to share research experience and expertise, and of course it was a pleasure to know your wonderful country. Just a short presentation. As you heard previously, I'm a food microbiologist. I'm an associate professor of food microbiology unit at the Department of Food and Drug of the University of Parma. And I'm also member of the Innovation Center CITEIA. We are very proud this year because our department has received a recognition by the Italian Ministry of the University and Research, the recognition of Department of Excellence for the quality of the research produced. And talking about research, my main research topic follow two directions. The first one is the study and employ of lactic acid bacteria in food, so food quality, but I'm also interested in the detection and to understand the behavior of undesired microorganisms like pathogens and spoilage microorganisms. And we have a great resource in our laboratory, namely UPCC, is a microbial collection. The name is UPCC University of Parma Culture Collection. We actually collected more than 6,000 strains belong lactic acid bacteria, isolated from different environments, mainly dairy environment, over the last 20 years. And we are convinced that our collection is a great reservoir to be valorized for traditional use. Probably you know one famous product of our region, Parmigiano Reggiano cheese, where these microorganisms are the main actors. But we are also convinced in the potential of our bacterial strains for alternative use, innovative application. And for this reason, we opened two research fields. One is innovation with the aim to develop and optimize fermentation processes to produce novel fermented products, for example, novel fermented beverage. And the other one is sustainability. And in this case, the aim is to use lactic acid bacteria to valorize waste and byproducts and to produce high value added compounds. This here we explore a lot of substrate, and I would like to talk about everything, but for time reason I decide to focus on the project Fermento funded by Emilia-Romagna region, and another project that is object of a patent. About Fermento, the idea was born because we realized that the global market of non-milk fermented products is steadily growing. And since it is known that lactic acid bacteria can improve the nutritional properties and the organoleptic future of food, we decided to ferment with this bacteria juice and puree to produce novel fermented products not yet available in the Italian market. The project of 3 years was funded by Emilia-Romagna region, and it was coordinated by Open Fields. Open Fields is a private company that offer innovation and consulting services in the agri-food sector. It manages innovation projects funded by public institutions or private companies. But Fermento has also involved other partners, and in particular local organic farms, a training organization, and a distribution company, namely Ecor Natura C. This partnership was very important because the strength of the project was the real technological transfer of the process developed to the producer. And the aim of the project was to produce two types of product, juice puree with viable cells for a refrigerated product, and juice puree with functional metabolites for a stabilized, pasteurized product. And following the interest of the partner, we decided to focus mainly in the second product. About the experimental plane, we use 5 metrics, chemically characterized, and we also use lactic acid bacteria for inoculum. We choose about 50 biotypes belonging to different species, and the selection was based on the previous work. We prepare mono and co-culture as inoculum, and we performed more than 600 fermentation. So the first step, considering the amount of sample, was the selection. And the first selection was carried out in our laboratory on the basis of the evaluation of microbial growth in the different substrates and a preliminary sensory analysis. But the second step of selection was carried out at Ecor Natura C in order to define the best process to scale up. And this selection was done by an acceptability test carried out by 10 non-expert panelists. Each fermented sample was assessed for sight, smell, and taste. And the results are very interesting because all fermented products were appreciated more than the control. And the comments of panelists were positive for all the metrics analyzed. Then we moved on the characterization of the product, and so we study the volatile profile, the total polyphenol content, and the antioxidant activity. About the volatile profile, in line with the sensory analysis, we observed an enrichment of aroma compound profile in fermented products, and especially we observed an increase of volatiles associated with sweet and fruity notes. Concerning the total polyphenol content and the antioxidant activity, no difference were observed between fermented and control, but intriguingly, we observed an increase of phenolic compound belonging to the class of phenyllactic acid derived from the metabolism of microorganism, amino acid metabolism, and these compounds are reported in literature to possess an high antimicrobial activity. The final step was the technology transfer. This step was carried out into the farm partners of the project. We also realized a nutritional table, and we tested the shelf life of the product, observing a great stability of the product at least until 3 months. So in my view, this is a successful example of a project funded by Emilia-Romagna region that led to a product innovation through the involvement of a food company and academia. But I would like to mention another innovation in the area of sustainability, which I believe is a very promising approach. It is a research about the production of extract with antimicrobial activity to be used in food, but not also in this field, also, for example, in cosmetic. as alternative to commercial preservatives. The aim of this patent is to reuse plant byproducts. We focus on 3 different substrates, tomato, carrots, melon byproducts, and the process patented include grinding of raw material, addition of microorganisms, fermentation, and a final extraction. Here you can see all the activity conducted, many activity, a lot of work. In the first part of the work, we focus on the optimization of a process, on the fermentation and extraction process, and also we focus into the production in adequate amount of the extract to be used for in vitro, in situ, and small pilot plant assay. And we also evaluate the antimicrobial efficacy on different targets, spoilage and pathogen microorganisms. In the second part of the work, we mainly focus on the characterization of the extract, and so to understand which molecules are responsible of the antimicrobial activity exerted. We also develop a prediction model, microbial prediction model, to assess the activity of the extract in the presence of other variable. And we also carried out a market analysis to understand, to identify possible stakeholders. So to conclude, I hope I have provided some insight into possible future collaboration, as I strongly believe that our experience gained over this year in the field of lactic acid fermentation and the strong tradition of Japanese culture in the world of fermented products can be a perfect match. Thank you.
Thank you so much, Camilla, for that wonderful presentation. Please put any questions that you have for Camilla in the Q&A box, and we will come back to them at the end of the webinar. Thank you very much. So up next, we have Keisuke Tobita, who is a researcher at the Ibaraki Industrial Technology Innovation Center. His presentation is titled Development of Technology to Visualize Alcohol Fermentation in the Manufacturing Process of Rice Wine. Tobita-san is going to talk to us about the research they have been doing using technology to reduce the workload involved in brewing Japanese sake, also known as rice wine. Over to you, Tobita-san. Please start your presentation.
So let me share my screen. So thank you very much for the introduction. I am Tobita from Industrial Technology Innovation Center of Ibaraki Prefecture. Thank you very much for your precious time to attend this seminar today. So from me, I am going to talk about development of technology to visualize alcohol fermentation in the manufacturing process of sake. So please allow me to introduce myself. So I live in Ibaraki Prefecture in Japan, which is located in approximately 100 kilometers north of Tokyo. And I specialize in the food fermentation, food immunology, and studies. And then usually I'm doing research of microorganisms derived from traditional fermented food and investigating on the health functions of organisms derived from fermented food, such as lactic acid bacteria, lactobacteria, and yeast. And I'm also supporting the production and development of fermented food for companies in Ibaraki Prefecture. So let me talk about Industrial Technology Innovation Center of Ibaraki Prefecture. So this center is a public research and testing organization run by Ibaraki Prefecture, and we have 3 locations. So in the main office, Research Institute of Polymers and Textiles, and then Kasama College of Ceramic, and we are providing various kind of services. So first of all, it is about the innovation. We are doing various kind of studies and then development. And then also, the next one is we are supporting startups and the creation of new business models. And then thirdly, we are providing contracted analysis and evaluation services. And then we are also organizing human resources development seminars and workshops. So this picture is where I am developing sake production technology. And then also, I am checking the sake quality, and sometimes I am participating as a judge or quality assurer. So, by the way, actually in Ibaraki, we have 35 sake breweries. So this is the map of Ibaraki. So the one you see with red stars are where the sake breweries are located. So there is a Kuji River water system, there is a Naka River water system, Kinugawa River water system, Tsukuba Mountains water system, and then finally Tone River waste system. So there are five different water systems. So the Japanese sake has a diverse range of flavors from 5 different water systems. So let me briefly explain to you about what is sake. So sake is a brewed liqueur or wine made from rice, and those are the 3 characteristics. The first one is the parallel double fermentation. So what does this mean? So this saccharification, which means conversion of starches into sugars, and fermentation happen at the same time in the same tank. Secondly, high alcohol fermentation. So this is quite unusual, but capable of producing alcohol content as high as about 20%. And then third is what we call kanzukuri, so which means that sake can be made in cold weather. Sake brewing is suited to climate and natural features of Japan during the winter months, during the cold climate. So let me briefly introduce you to the overview of sake production process. So there is a kobo, yeast, and then steamed rice, and then koji, rice malt, and water. So they are mixed together to make moto, a yeast starter. And then this is fermented for about 10 days. Then, after that, again, steamed rice, rice malt, and more water is added to make fermenting mash, moromi. And this is fermented for about 30 days. Then when it's pressed, it becomes sake. So, background to our research and development. So in making a moto, we need to make sure that yeast and then steamed rice and then koji are fermented, and then here the yeast needs to be multiplied. So this is a very important process in this process of making moto. So here the yeast multiplies, and then the sugar produces alcohol. Then in this moto making process, this adequate level of yeast multiplication is important. So this analysis of the components such as alcohol, measurement of temperature, etc. is very important. However, conventional way of analysis and visual measurement of temperatures creates an intensive workload on operators. And sometimes it delays the timing of implementing measures, including temperature control. So what we developed this time is to make the alcohol concentration assumption without having the direct contact estimation of alcohol concentration through amount of CO2 emission. So I'm going to show you how. So this is the process of alcohol fermentation. So the glucose molecule is here, and then there is 2 molecules of ethanol, and then there is 2 molecules of carbon dioxide. So this is a fermentation. But this alcohol concentration, because of the pre-processing, and then also requires a special type of sensor, it is actually quite difficult to take the measurement. And then so we decided that maybe we thought we could take the measurement of the CO2, which can be measured by the general purpose sensors. What do I mean by that? So we thought we can estimate alcohol concentration by amount of CO2 emitted. So the CO2 emitted from the yeast starter motor during the fermentation will give us an indication of alcohol concentration. So we have the CO2 sensor is attached, placed, and then we take the measurement of the CO2 sensor from motor. Then this is to show you the result of after 6 days of fermentation. So the black dots are the actual measurement of the alcohol concentration in motor, and this line, red line, show you the CO2 cumulative value. And as a result, we can see that there is a strong correlation between the alcohol concentration and the cumulative CO2 value, correlation coefficient of 0.99. So as a summary, so we developed technology for non-contact estimation of alcohol concentration, and as a result, when we actually took the measurement of the alcohol concentration in the motor, we could see the strong correlation between alcohol concentration and cumulative CO2. And this means that demonstrated that alcohol concentration can be estimated with a single regression equation. So in the process, we have been successful in making the visualization of techniques for alcohol fermentation in the sake production process. These results are expected to help reduce workload and save time for brewery workers. So like I mentioned earlier, the sake in Ibaraki have varieties and diverse flavors. So I hope that you people in Italy are also going to have the opportunity to enjoy the flavor of a sake one day. Thank you very much for listening.
Thank you very much, Tobita-san. Everyone, please put your questions for Tobita-san in the Q&A box below, and we will come to them at the end of the webinar. Up next, we have our last speaker from the Emilia-Romagna side. We're going to hear from Patrizia Alberti, who is from the Directorate General for Agriculture, Hunting and Fishing. She's going to tell us about the various agricultural knowledge and innovation systems in Emilia-Romagna, including the operational groups they have running to support the agricultural and forestry sectors. Over to you, Patrizia. Thank you.
Thank you. It's okay?
Yep, that's great. We can see that.
Allora, good morning. And today it's a pleasure for me to talk about agriculture knowledge and innovation system in Emilia-Romagna. In Emilia-Romagna, there are 2 ways to support innovation for agriculture system. One way is operational groups. Operational groups to support innovation in agriculture system with a bottom-up approach and bring together multiple actors like farmers, researchers, advisors, entrepreneurs of agri-food sector, environment groups, consumer interest groups, or over NGOs together. And together we together organize to resolve a question, a problem, and the target are modernization or farmer and forestry, diversification, biodiversity, water quality and water resource efficiency, soil quality, renewable energy, mitigation of ammonia and gas emission, environmental forestation. And in Emilia-Romagna, through the Regional Rural Development Program 2014-2022, is a program of European Union. There are funded 234 operational group. Total investment for this operational group are 29 million euro. And there are another way to support innovation in agriculture. The way is a pilot project. In a period 2014-2022, we realized 80 pilot projects. 51 realized for support supply chain, and there are any 30 realized with individual company, but over project support competitiveness for increase competitiveness, ensure high quality agriculture, and raise the level of innovation. But for to increase knowledge and innovation in agriculture system, it's important to finance training course, advice and consulting activities, study visit and exchange between producers. And Emilia-Romagna, with the rural program development, support a measure like a green catalog, where the farm to found a training course and start visit and exchange between the producer. But it's important to dissemination of the result of project innovation like a pilot project of operational group. And in this period are financed 19 demonstration projects. And the resource total to support innovation and knowledge system in general in the period 2014-2022 are over 100 million. And in this period, 2023-2027, more short, We support the AKIS, Agriculture Innovation Knowledge System, for 21 million euros, corresponding to 58% of total resource. It's important to record Emilia-Romagna is the first region in Europe to implementation of a measure supporting innovation of the agri-food sector, ensuring cutting and a commitment for a positive future for agriculture. Because it's very important to sustainable innovation to realize agriculture system sustainable from point of view competitive, environmental, and social. And for this program, there are 10 objectives, and knowledge innovation support 9 objectives, like food value chain, climate change, environment care, landscapes, generational renewal, rural area, food, and health. Thank you very much, and I'm available for any question. Thank you.
Thank you so much. If anybody has any questions for Patrizia, please put them in the Q&A box, and we will come to them shortly when we're done. So next, we have our final speaker of the day. We have Shin Yoichi from the Tsukuba Life Science Promotion Council. He will finish off today's webinar by telling us about the ecosystem of Tsukuba Science City in Ibaraki Prefecture and the work that Tsukuba Life Science Promotion Council does.
Good morning, everyone. I'm Yoichi Shinma at University of Tsukuba. Thank you very much for giving me this opportunity. I'd like to introduce the ecosystem of Tsukuba Science City as the advisor of Ibaraki Prefecture. Ibaraki Prefecture is located here in Kanto Plain. Warm current and cold current collide in the Pacific Ocean off the coast of Ibaraki Prefecture, resulting in the coexistence of northern and southern climates. Thanks to this diverse and favorable climate, variety of plants grow. Ibaraki Prefecture ranks third in terms of gross agricultural production. Ibaraki Prefecture is the largest producer of melon, chestnut, beer, chicken egg, and natto. Do you know natto? Natto is a traditional health food by making by soybeans, fermented soybean with bacillus. And there are many fermented food in the world, such as bread, beer, wine, yogurt, pickles, cheese like Parmigiano Reggiano using yeast and lactic acid bacteria. On the other hand, as a fermentation culture unique to Japan, there is Aspergillus oryzae, shown in red line. It is a domesticated fungus, just like pigs and wheat, and it's known as the national fungus, just like the cherry blossom is the national flower in Japan. Aspergillus oryzae is used in the production of sake, miso, and soy sauce, and cosmetics and pharmaceuticals are also manufactured by Aspergillus oryzae. Furthermore, many fermented foods such as rice bran pickles and many kinds of cheeses are fermented using various microorganisms like these. We have rich food technologies. Joint research between Italy and Japan would lead to the development of innovative technologies. By the way, Tsukuba is the largest science city in Japan. Based on national policy, 1/3 of Japan's National Research Institute and more than 100 private research institutes are concentrated in Tsukuba City. For example, National Institute of Advanced Industrial Science and Technology, AIST, National Agriculture Food Organization, NARO, University of Tsukuba, Riken, Japan Aerospace Exploration Agency, JAXA, Eizai, Kirin, Kyohakko Bio, and so on. And there are many science communities that promote collaboration between these institutes. Tsukuba Innovation Arena, TIA, is a research base operated by 60 institutions like this. TIA offers joint research with private companies using open research facilities. Another organization is Tsukuba Life Science Promotion Association, TLSK, which was established with over 60 institutes and companies around Tsukuba City. TLSK has world-class biomedical resources such as Tsukuba Human Tissue Biobank and Riken Bioresource Center, which are conveniently available to TLSK members. And TLSK established collaborative graduate school with the University of Tsukuba. In this graduate school, researchers from TLSK member can become a professor at the University of Tsukuba, and company staff can become a graduate school and can study in the laboratory of TLSK members such as Astellas, Eizai, Riken, AIST, NARO, Nippon Ham, using their very special research facilities. Ibaraki is a highly industrialized prefecture. Area of industrial land is the largest in Japan. Ibaraki Prefecture locates in the corner of the Tokyo Metropolitan Economic Area, which accounts for more than 30% of Japan's economy. Recently, high-speed railway Tsukuba Express, Ibaraki Airport, Metropolitan Intercity Highway were opened. A vast, convenient, undeveloped land has appeared in Ibaraki Prefecture. So land price in Ibaraki is relatively cheap, 145 euro per square meter, 1/10 of Tokyo, 1/3 of Saitama Prefecture. So you can save entry cost. Furthermore, Ibaraki Prefecture offers various subsidy systems. Joint research trial subsidy is up to 2 million yen, around 12,000 euro will be provided to the foreign companies. Subsidy for the establishment of project facility is up to 6.4 million yen, around 40,000 euro. Set up visa, you can stay in Japan for up to 1 year. So for all these reasons, I believe that Ibaraki Prefecture is the ideal location for research and development. Let's grow our business together. Thank you for having me.
Thank you very much, Shinma-san. Everyone, if you have any questions for Shinma-san, please put them in the Q&A box. And as I speak about the Q&A, we are now going to move on to the Q&A section. So to start us off, I have a question for Giuseppe Moscatelli from Mina Ikemoto Ghosh. Her question is, thank you for your presentation. This air washing technique of the gas loop project requires sulfuric acid. Are there any alternatives being trialed in case of a future sulfuric acid supply shortfall? If much of our sulfuric acid comes from waste products of our fossil fuel consumption, if we shift to renewable energies, sulfuric acid supply would decrease and perhaps increase the cost of the gas loop device.
Good questions for the future. We use sulfuric acid because now is very, very cheaper, very common, and because it is a strong acid. Of course, in the future, sulfuric acid could become less available because derived from the fossil fuel treatment. In this way, our acid are welcome to be used, like nitric or phosphoric acid. These two acids are more and more expensive than sulfuric acid, but could increase a lot the economic value of the recovered fertilizers, because ammonium sulfate is a cheaper fertilizer with a low content of nitrogen. But ammonium nitrate has a higher content of nitrogen, and ammonium phosphoric has nitrogen and moreover phosphorus for the crop production. Moreover, other acid byproduct from agricultural agro-industry sector can be used as citric acid, but this acid is not so strong.
Brilliant. Thank you very much for that detailed response. Up next, we have a question that came to us in the registration form for Yamamoto-san. Yamamoto-san, the question is, are there hydroponic crops in Japan?
Hydroponic crops in Japan, well, rice. For example, we use a hydroponic. Probably rice is example. I'm afraid I'm not very knowledgeable about that.
Thank you very much. Up next, we have another question from the registration box for Sukegawa-san. Sukegawa-san, do you think pig farming will get to a point where no human farmers need to be involved?
Thank you very much. So in my idea, I don't think it will get to the level where no human resources are involved. Of course, we are going to be using the technology with AI, but this cannot do everything. And most importantly, when it comes to looking after the pigs, we need some physical presence of the people to look after them. And then so this is where we need the involvement of the people, especially when it comes to leading with the livestock. But when it comes to the number of people involved, this support from the AI may be very more efficient. So for example, one person can look after more number of pigs, or a person doesn't have to go to the the pigs center more frequently, less frequently. So that's where we will be able to use the AI-based technology.
Thank you very much, Sukegawa-san. Next, we have one that came to us in the chat privately for Tobita-san. Can the techniques used for visualizing fermentation in sake or rice wine also be applied to other products?
Thank you very much for your question. Yes, I think it is possible. So, for example, the alcoholic fermentation, for example, wine, and then also any brewed liqueurs, we can definitely apply this technology too.
Thank you.
That's all from me.
You. And we have another question, which is for Camilla Lazzi, but also perhaps open to other thoughts and opinions from other speakers. But the question is, the stereotypes of Japan and Italy are very different. Do you think this can somehow benefit you in working together?
I don't know if I understand the right question is about the sensory analysis, the panel test. Probably, yes.
It's about the cultural differences between Japan and Italy. So if you want to work together, do you think that these strong cultural differences can actually benefit you in collaborating on research?
Yes, I think that the result of fermented products, the fermented products can be appreciated in both countries. And so for me, it's very interesting to collaborate to explore this aspect, but I think that we are the possibility to explore different strains of our collection and so differentiate the product, the final product, to define the best strains for a product for the Italian market, but also for Japan market. So yes.
Brilliant, thank you very much. And also, I mean, just as this is a more open question, do anyone else from our panelist speakers, does anyone want to add anything on collaboration between Japan and Italy? If not, we can move on. Or does anybody have any other questions that they would like to add in the Q&A panel, or even if any of our... Oh, hello, Patrizia, please go ahead.
No, it's okay. Thank you.
Okay. Well, in that case,
sorry, Anna, probably if I can talk about my opinion, sorry. I saw a lot of common interest among between Ibaraki Prefecture and Emilia-Romagna region, and probably I think could be useful to create a working group in each area of collaboration to prepare program for research mobility, exchange in teaching exchange for academic, but also to prepare project for a call, or and probably we have a lot of common interest. Yes.
That's wonderful. Thank you so much, Camilla. If anybody has any other questions, here on this final slide, we have Sauko Oyama's contact details from CREAB London, if you have any final questions that didn't get answered this time. So that's it for our webinar. I'm going to hand back over to Jeremy Walker to finish off the webinar. Thank you to all our speakers and all the attendees. Thanks so much for joining. Off you go, Jeremy.
Thank you, Hannah. Yeah. So yeah, many thanks to all of our speakers today for their fascinating insights and presentations. And obviously a special thank you also to the Governor of Ibaraki and President of Emilia-Romagna for their welcome address. We'd also like to thank all of you for attending today, and we hope you found this webinar to be informative and interesting. As Hannah mentioned, if you have any questions or would like any further information, please reach out to Sayoko Oyama, whose details are on the screen below now. And with that, all that's left to do is to wish you all a pleasant rest of your day, however long that might be where you are. So arrivederci, sayonara, and goodbye.